Welcome back. Bill Witte here with more pre-algebra. You know, a test is looming, and I got to tell you, you can fool all the people some of the time, and you can fool some of the people all the time, but you can't fool math ever. You better make sure that you're completely prepared before you go take these tests. What I mean by is make sure you do your homework, and I mean do a variety of problems in the software. And for crying out loud, number one, make sure that you've done that practice test. You're not going to fool anybody once you get there. If you couldn't do the practice test, you can't do the real one. Okay? So make sure that you've looked at it and make sure that you've successfully done it or asked questions. Find out how. Let me know. Okay? You can email me, or you can always go to the homepage at www.montgomerycollege.edu/pre-algebra. Okay? So let's do some pre-algebra. What do we got today? I don't know.
A stranger from the outside.
Oh, we've never done that. We've never done least common denominators.
And another thing.
Oh, we got more to cover today. We're going to use them.
Mayday! Mayday! Come in, Star Command. Send
We're going to use
reinforcements.
those to add fractions, okay? It doesn't get any harder than adding fractions in this class, okay? So let's take a look. Before we look at that, let's review what we covered yesterday.
I say, old chap.
We talked about fractions. We began with basic fraction vocabulary. For instance, in this picture, we're going to define a fraction by the number of chosen pieces over, well, that's called the numerator, over the total number of pieces. That's called the denominator. The numerator over the denominator. In this case, we've got 3 chosen over 5 total. So you've got a picture here of 3/5. Okay? Now, how do these fractions that we've defined look in reality? Where are they on the number line? You've got to be able to imagine them, get a picture of them, or, it's not going to make much sense to you. Well, for instance, halves. There's 1, there's 2, and I've divided 1 into halves, okay, in 2 halves. There's 1/2. There's 2 halves. Note what 2 halves is the same as. There's 3 halves, or 1 and 1/2. There's 4 halves. Note what 4 halves is the same as. It's the same as 2, isn't it? What about the number 1 as a fraction, written as a fraction? In thirds, 1 would be 3/3. Here we are on the number line. In halves, as we saw before, it's 2 halves. What about fourths? 4/4. You noticed a pattern, I hope. Anything over itself. 3/3, 2/2, 4/4, hiya over hiya. Anything over itself.
That's the fact, yeah.
Is 1. Note that, please. You'll need to know that. We use that for a lot of things, okay? In fact, one of the things we used it with was the division property of 1. Remember what that was?
You are correct, sir.
Anything over 1. Now, we used to say anything divided by 1, but in a fraction, the top is divided by the bottom. Anything over 1 equals itself. 5 divided by 1 is 5. You know why? Let's work backwards, because 5 times 1 is 5. Same thing with fractions. We're dividing by 1. X over 1, or x divided by 1, is x. Anything over 1 is itself. Why? Go backwards. X times 1 is x. Get the idea? Top divided by bottom?
You're absolutely correct.
Anything over 1 equals itself. What about these zero properties? They were tough, and you needed to know them. In English, there's 2 division properties of 0.
That's the fact, yeah.
0 over anything equals 0. Makes sense. 0 divided by 5 is 0 if we work backwards, because 0 times 5 is 0. Same thing with division here. 0 over 2, or 0 divided by 2, it's also going to be 0. Because, let's work backwards with our multiplication. 0 times 2 is 0. Okay? So, 0 over anything equals 0. But you don't even have to remember that. You can just work backwards. Okay? I think you'll need to do that when we look at the next division property of 0. Okay? You don't want to mix them up. Just always check. The second property of 0, or division property of 0 if you would, in English.
Houston, we have a problem.
Uh-oh. Anything over 0 isn't 0, but is undefined. Think about this. We know 24 divided by 6 is 4 because, let's work backwards, 4 times 6 is 24. Same thing we did before. But 24 over 0, what could that be? What's an educated guess?
Are you pondering what I'm pondering?
Well, it can't be 24.
Wait a minute.
Because 24 times 0 doesn't equal 24.
Go!
Okay?
I haven't got a brain.
Well, it could be 0. That's an educated guess, but it isn't. You know why? Because once again, working backwards,
You're despicable.
0 times 0 doesn't equal 24.
Go!
So you know what? You can't tell me anything times 0 that equals 24.
Uh-oh.
So, consequently, anything over 0, we don't have a definition. We don't have anything. So anything over 0 is undefined. But don't remember when it's in the top, when it's in the bottom. Okay? Just remember, always multiply back and check. Okay? The less you have to memorize, the easier it is. Okay? Multiply back. Okay, what else we got?
And another thing.
Oh. Fractions were equivalent if they were the same length on the number line. 1/2 is equivalent, if you would, to 2/4 because they equal the same amount on the number line.
Well, ooh-la-dee-da.
Well, that's going to be important in the future.
And another thing.
Another reason why equivalent fractions have the same value is your old buddy, the multiplicative property of 1.
What happened?
Well, what we did here was we actually multiplied by 1 in one of its fancier forms, 2 over 2. Or we divided, I'm sorry. 2 divided by 2 is 1, and 4 divided by 2 is 2. So, son of a gun, remember, if you divide anything by 1, you get itself. So 1/2 must be the same, maybe a little disguised, as 2/4. That's your division property of 1. Remember we covered composite and prime numbers. Composite numbers
I'm gonna blow you to smithereens.
were numbers that you could break up, you could blow up. For instance, 14 breaks up into 2 and 7.
I'm gonna blow
See what I mean?
you to smithereens.
6 is a composite,
I'm gonna blow you to smithereens.
because you can break him up into 2 and 3. Now 13, you can't break up. So it's called prime. You can't break it up into anything other than 1 and itself. Can't break it up. 5 is prime. Can't break it up into anything other than 1 and itself.
What a maroon.
And you know what? We don't count
What an
1,
ignorant
okay? Because you'd be going on forever, okay? Got the idea? Well, the reason we needed to know about prime numbers is that we're breaking numbers up into their prime factorizations. Okay. Prime factorization is when you break things up as far as they'll go. Let's try it with 28. I'll start by breaking them into any two numbers. I know a 4 goes into it, so 4 into 28, 7. Okay, now 7's a dead end, but 4 can be broken up further. 2 and 2. Now I got all dead ends. And that's the prime factorization, because we can't break it up anymore.
That does it, Boo-Boo. A job well done.
Note that the numbers are put in order. 2 times 2 times 7. We generally do that.
Thank you, sir. May I have another?
Let's do one more because we're going to be doing a lot of these. Let's break up 90. Break it up into 9. 9 and 10. How about that? Now 9 I can break up into 3 and 3, and they're dead ends. They're prime. 10, oh, he can break up further. 2 and 5. Now,
here is today's final Jeopardy answer.
we're going to put them in order. Perfect. And that's the prime factorization. 2 times 3 times 3 times 5. There's the deal. You know what we use? Remember what we use that for? We use that to reduce things and to multiply and divide and canceling. For instance, to simplify this,
I'm gonna blow you to smithereens.
we broke it up into prime factorizations, both numbers. 8 is 2 times 2 times 2, and 12 is 2 times 2 times 3. So I canceled, basically divided by 1, and the answer is 2/3.
What happened?
Well, what you really did there, hope you appreciate, is divide by 1 in one of its fancier forms. 2 times 2 is 4, and 2 times 2 is 4. And we know anything over itself is 1, so you're allowed to divide by 1 all you want. 8 divided by 4 is 2. 12 divided by 4 is... And that's really what we did. Okay? Now remember multiplying fractions last time. We covered a lot. A over B times C over D, you just multiply. It's A times C over B times D. For instance, let's just multiply 1 times 5 over 15 times 11. Now remember what I reminded you to do last time. Rather than multiply these large numbers, if we can...
Wait a minute, 99. That gives me an idea.
Let's cancel first. Now 15 and 5 are both divisible by 5. 5 goes into 5 once, and 5 goes into 15 3 times, and now I got some nice small numbers, and I got an easy answer. 1 times 1 is 1, and 3 times 11 is 33.
Party on, Wayne. Party on, Garth.
That's the way to go.
Now what am I gonna do?
Remember division, very much like multiplication, in that to divide two fractions, I multiply by the reciprocal of the second fraction. Just multiply by the reciprocal. For instance, in this problem, I'm going to take 7/8 and multiply by the reciprocal. And now I got a multiplication problem. But remember,
Wait a minute.
let's cancel before multiplying. Make it easier. Let's see, 2 goes into 2 once, 2 goes into 8 4 times, and now it's easy to multiply.
Yes!
And it's not so bad.
Excellent.
Okay?
And another thing.
We did one more thing last time, and that was once you had solved an equation and got a fractional answer, we wanted to learn how to check it. In this case, 3x plus 12 equals 5. Our friend Jim got an answer of -7/3, and he wanted to check it. So we put -7/3 in instead of x. See what's happening? Okay, now he had to multiply. You're like, ooh, I don't like that. Well, remember,
Well, ooh-la-dee-da.
any number is itself over 1. Okay, so we can cancel anything in the top with anything in the bottom, and now it's not so bad. -7 plus 12, what does that add up to? 5, and anytime the left side equals the right side,
Oh, he got all of that one.
you know you're right. If it doesn't equal the other side, you're not correct. Okay?
Thank you, sir. May I have another?
Okay, let's give you one where they're not correct. I'm going to take 6x minus 5 equals 7 and put in a half. Okay. 6 over 1,
This crowd has gone deathly silent.
because
Cinderella story out of nowhere.
here we go. 6 over 2 are going to cancel.
Oh, he got all of that one.
Cancel the 2 with the 6, and I get a 3. Now, 3 minus 5, does that equal 7? Or 3 plus -5? It doesn't.
Wait a minute.
So that means he must have gotten the wrong answer.
He's dead, Jim.
So you better check it, Jim, okay? Okay, it's time for the new stuff. You ready? This is advanced fraction stuff.
It's always best to start at the beginning.
Yeah, we're going to cover least common denominators first. Let's take a look. Factors and multiples. You know what those words mean? Look at 30. What are the factors of 30? 3 is a factor of 30 because it goes into it. You could multiply something by it. 5 is a factor of 30 because it goes into it evenly. 2 is a factor of 30. It goes into it. 13 isn't a factor of 30. Okay, so those are factors.
Well, isn't that special?
Multiples, a multiple of 30 is 60. It's a number that number goes into. Another multiple of 30 would be 90, because 30 goes into 90. Many multiples. Another multiple of 30 would be 120. And how many factors do we have? Not many. How many multiples do we have?
To infinity and beyond.
It goes on, okay? So you have way more multiples. Get the idea? Let's do it with 45. What are some factors of 45? Well, 3 goes into it evenly. That's a factor. 5 goes into it. That's a factor. 15 is a factor of 45, isn't it?
Well, isn't that special?
What about multiples? Let's get the difference here. Well, it's its own multiple because you can multiply by 1. 90 would be a multiple of 45. 135 would be a multiple, and so on.
To infinity and beyond.
You can go on and on and on. So that's the idea. Now, I'm looking at these two numbers, 30 and 45, and I note
Great horny toadies.
they have the same multiple sometimes, okay? That would be called a common multiple of these two numbers. Now we have a fancier word for common multiples that we're going to use with fractions.
That's the fact, Jack.
We're going to call them common denominators, okay? It sounds kind of crazy, but same principle. Common multiples, common denominators. Let's show you how to create a least common multiple or a least common denominator. I'll give you a way that always works. What we're going to do is break up the factors, the numbers, as far as they'll go. You're using your prime factorizations here, aren't you? Yep. And then we're going to actually construct a number that contains every factor from both sets at least. Okay, we want it to be small, so we're not going to have it contain any more, but at least that much. We're going to construct it.
Allow me to demonstrate.
Let's take a look. What is the least common denominator of 6 and 35? Well, let's break 6 up. That's as far as he'll go. That's his prime factorization. Let's break 35 up. 5 and 7. Okay, that's it. That's all prime as well. Now, I got to create a number that has all of those numbers in it. I got to have a 2. Okay, I got him. Got to have a 3. Okay, I'm good to go there. Now I got to have a 5 from the 35. Got him. And I got to have a 7. Okay? And those are all the factors. If this number is going to have 6 and 35 go into it, it has to have all those, doesn't it? So let me multiply them so that I can get that number. Let's take roll, make sure everybody's in there. 6, you in there, there he is, 2 times 3. 35, you in there, there he is, 5 times 7. So they both go in, and this is the smallest number that they both go into.
Holy heart failure.
Yeah, I don't think you could have done that in your head. So the least common denominator of these two numbers is 210, okay? It's a good method because it always works.
That does it, boo-boo. A job well done.
Well, you probably want another one.
Now I say look at here.
Okay, let's do another. 20 and 15. Maybe you could do that one in your head, but let's use the same method. Let's break 20 up as far as it'll go. 4 and 5. Now 4 can go further. All the way, baby. Okay. And that's as far as 20 can be broken up. 15, not so bad. 3 and 5. And that's his prime factorization. Now, we got to cover our tails here. We got to make sure everybody's covered. So let's start constructing this term. I need a 2. Actually, I need 2 2's, don't I? Or 20 won't be in there. I need a 5. Okay, now, I need a 3, and I need a 5. But I already got a 5, so don't make trouble. We don't have to make it. As long as I have one, I'm covered.
Oakley dokley doo.
So that's okay. I don't want to make it any bigger than it has to be. So I multiply these, and son of a gun, 60 is the smallest number that both 20 and 15 go into. There's your least common denominator. 20 in there? Yep. 15, you in there? Kumbaya.
Oh, gnarly!
We've got a least common denominator, which is going to be of great use to us in the future.
Do that again.
One more. 8 and 6. 8 breaks up into 4 and 2. 4 can go further. Okay, now there's your endpoints. Now 6 will break into 3 and 2 or 2 and 3. Now let's construct this term. Need a 2. Actually, I need 3 2's, don't I? Okay, now, I need a 3. I don't have a 3 yet. And I need another 2, but I already got a 2. So you're good there. So let's multiply these. And what do we get? Well, before we multiply, let's take roll. Is 8 in there? There he is. Is 6 in there? There he is. They can overlap as long as they're in there. Okay? And that multiplies to 24, and that's the smallest number that both 8 and 6 go into. Hence we call it the LCD, or least common denominator.
Thank you, sir. May I have another?
Last one. 42 and 6. Let's break 42 into 6 and 7. Oh, 6 can break further. And that was my endpoints. Let's break 6 into 2 and 3. This is important that you can do this. That's why we're doing it so many times. Now let's construct. I need a 2, I need a 3, and I need a 7. Now I need a 2, but I already got a 2.
Oakley dokley doo.
I need a 3, but I already got a 3. Now if I needed 2 3's, then I have to add another 3, but I'm good to go. So son of a gun, that's it. 2 times 3 times 7. Take roll. 42 in there? Yep. 6 in there? Yep. I should have known that it was 42, because 6 goes into 42. Son of a gun.
You're absolutely correct.
Sometimes it's just easy. Okay, that's LCDs. What are they good for? Well, we're going to have to add what we call rational or rational expressions, same fancy word for fractions. Let's take a look.
This thing isn't as black as it appears.
Well, when the fractions have the same bottoms, it's easy. For instance, 4/3 plus 1/3. You got 4 of them, you got 1 of them. Just add the tops.
Totally.
It's 5/3.
Dismissed.
That's not so bad, is it? With the similar denominators, all you got to do is add the numerators. 7 over y, uh-oh, a letter. Fear not. 2 over y, just add the tops, add the numerators.
Oh, gnarly.
9 over y, it wasn't so bad.
Dismissed.
I'm telling you, when the denominators are the same, you just add the numerators. It's easy when the denominators are the same. What are we going to do if they're different, though? Uh-oh.
Now what am I gonna do?
Well, to add fractions with different denominators, we're going to make them the same. We're going to change the problem into something that we already know how to do, the easier one we just showed you. We're going to find a least common denominator, and then we're going to create fractions that are equivalent to the original problem that have the same denominator. That's the common denominator. Once you have fractions with the same denominator, my mother can do it. Just add the numerators. That's our goal here, okay? You're saying you need an example?
Oh, let's get ready to rumble.
Okay, let's see. I'm looking at my denominators here. 3 and 2. 4/3 plus a half. Well, I need a common denominator.
Here I come to save the day.
What's a number that both 3 and 2 go into? Yeah, we did that one in our head. 6. That's the least common denominator. Okay, now we're going to create equivalent fractions. Something that's equivalent to 4/3 that has 6 as a bottom. What I have to do is ask myself, what did I multiply 3 by to get 6? I multiplied by 2. So 4 is saying, hey, what about me? You got to give me that. Multiply 4 by 2. So you see, whatever you do to the bottom, you have to do to the top. The reason I can do that is because I'm really multiplying by 1. And remember, the multiplication property of 1 is that you can, anything times 1 is itself.
Oh.
So that's the reason you can do this. So I get 8/6. Okay, let's do the bottom. What did I multiply 2 by to get 6? A 3. So 1's saying, hey, what am I, dog meat? I want a 3 as well. So that I'm really multiplying by 1. Okay, no problem. You get the 3. Well, now I got fractions that have the same bottom.
Oh, no!
And it's easy. 8/6 plus 3/6 is 11/6.
Genius! That's what it is. Sheer genius!
That's all you got to do. It's not so bad.
And another thing.
Let's look at another one. Ooh, this is one that has a tough LCD, but I'm assuming you could find the LCD because we showed you how to do that. Okay? And we're going to subtract as well here. Well, the least common denominator, you're going to have to trust me, of 18 and 12.
Here I come to save the day.
Always the savior.
Yes!
Is 36. Okay? Now, how are we going to complete this? We're going to create equivalent fractions. What did I multiply 18 by to get 36? Well, 2. So what do I have to do? If I do it to the bottom, I have to do it to the top. Why do I do that? Because I'm really multiplying by 1. Okay, that's okay. That's hunky-dunky.
Ooh, yes.
Okay, so 5 times 2 is 10. Now let's see. Let's look at the bottom fraction. 12 times what is 36? 12 times 3. So 7 times 3, there's your buddy 1, is 21, or minus 21 if you would. So we have 10 minus 21.
Oh, gnarly!
Not so bad. You know your negatives. Is negative 11 over 36, and that's your answer.
You look marvelous.
Not so bad.
Uh-oh.
Uh-oh. Something with letters. Can we do it? Use the same idea. First step, get a least common denominator. 13 and 26.
Here I come to save the day.
We can do it.
Woohoo!
It's 26. 13 goes into 26. Okay? Now, we've got to create these equivalent fractions. What did I multiply 13 by in the top fraction to get 26? 2. So, same rule. Got to multiply the top by 2. What's 5x times 2? 10x. Now let's look at the bottom. We're halfway home. I multiplied 26 by 1, so I got to multiply 3 times 1. Sometimes it's only 1. Not too much work to do there. And now,
Wait a minute.
just add, all you have to do is add the top terms. And you can't. So 10x plus 3 over 26, and that's it, Buford.
Brilliance. That's all I can say. Sheer, unadulterated brilliance.
Pretty cool, huh?
Oh, I can't take it anymore.
We can do this. Let's do one more. You can handle it. Got a negative, a positive, and a negative. Ouch, we need a least common denominator of 5, 3, and 10. It's got to be common to everybody now.
Holy heart failure!
You can do it. Let's see, 5, 3, and 10.
Here I come.
The least common denominator is 30, the smallest number that all three of them go into. Okay, now let's create our equivalent fractions. 5 times what is 30? 6. So minus 2 times 6. Minus 12. Don't lose your minus. 3 times 10 is 30, so 1's saying, hey, what about my 10? And then you got 10 over 10. There's your buddy 1. Okay. Now, in the bottom, 10 times 3 is 30, so minus 3 times 3 is minus 9. Well, now we have fractions with all the same bottom. All we have to do is add the tops, negative 12 and 10 and negative 9. Can you do it? What do they add up to? Negative 11 over 30. And that's your answer. Okay?
And now, ladies and gentlemen, for our next attraction.
Let's take a look at mixed numbers. What are mixed numbers?
It's always best to start at the beginning.
Well, let's talk about proper and improper fractions before we talk about mixed numbers. Proper fractions.
I say, old chap.
Proper fractions are fractions that are less than 1. Basically, you can think of it, I mean, that's what fractions are for, to break things up. They're less than 1. 1/2.
Jolly good.
And you know how you're going to know that it's less than 1? The numerator is less than the denominator. I'll give you another example. 3/8. That's less than 1 because the numerator is less than the denominator. Of course, in this case, 8/8 is 1, so 3/8 would be less than 1, okay, because the top's smaller than the bottom. So a proper fraction is less than 1.
Well, this is all very sophisticated.
But we want to know what an improper fraction is, perhaps.
Hey, join the party!
An improper fraction is the opposite, is greater than 1. In other words, the top is greater than the bottom. The top is greater than the bottom makes it an improper fraction. Here's another one. 3/2 is an improper fraction. It's greater than 1, or the top is greater than the bottom. 31/12. That's an improper fraction. Get the idea? Okay. Now, mixed numbers, on the other hand, are both. Part number, part whole number, and part fraction. As you can see, 3.5 is part whole number, 3, and part fraction, half. 1 2/3, part whole number, 1, and part fraction, 2/3. Get the idea? Now, why treat things as mixed numbers like that? I'll tell you why. Because when they're treated like that, they're way easier to look at on a number line. It will be way easier to find 3.5 on the number line. Let's take a look. Where is 3.5 on the number line? There he is, 3.5. Okay, it was real easy to find. It was a half more than 3. 1 2/3, it's close enough. It's closer to 2 than it is to 1. But you see how easy mixed numbers are to find on the number line. And that's one of the advantages of mixed numbers. Okay?
Go!
The problem with mixed numbers is they're hard to manipulate. They're hard to add, multiply, divide, etc. Okay? So you know what we may end up doing? Have a secret to change them into another form. That other form is improper fractions. That's what we're going to change mixed numbers into.
Who cares?
I'll tell you why you care. While mixed numbers are easier to graph, you want to be able to go back and forth, improper numbers are way easier to manipulate. Let's see how we're going to do this. We're going to divide the numerator by the denominator. That quotient is the whole number, part of the mixed number, okay? And then the remainder is going to go over the denominator as the fraction part, okay? So we're going from improper to mixed here. We're going to have to do both, mixed to improper and improper to mixed. So we're going from improper to mixed. Let's try it. 7/2, that's improper. I want to go to mixed so that I could graph it. Well, let's see. I'm going to divide the numerator by the denominator. 7 divided by 2, and it goes in how many times? Goes in 3 times. Okay, so that's the whole number with a remainder of 1. Well, so I'm going to have 3, the quotient. That's the whole number part. And then the remainder I'm going to put over the original denominator. The remainder is 1, and I'll put that over the original denominator, 2. So 7 over 2 could also be written 3/2.
Cool.
Get the idea? Why would we do that? Because it's easier to graph.
Do that again.
I knew you'd say that. How about 5/3? How could we write that as a mixed number? Well, let's see. Let's go through the steps. We're going to divide the numerator by the denominator, because that's really what the fraction means. And what do we get here? Simple division, 5 divided by 3, goes in 1 time. We have a remainder of 2 this time. Okay? Now we're going to take that quotient, that answer, that 1, and that's going to be the whole number part. And then we're going to take the remainder part, put it over the original denominator, and that's going to be the fractional part.
Excellent.
Not so bad, is it? That's how we're going from improper fraction to mixed number. Okay, wait a minute. Let's go backwards. Mixed numbers to improper fractions. How are we going to do that? The steps are going to be, well, before we do that, we're going to need to remember a couple things. First of all, remember what 1 is as a fraction. You remember that, for instance, 3/3, 2/2, 4/4. Remember that anything over itself, 3/3, 2/2, 4/4, anything, hooty-doody over hooty-doody, it's still 1, right? That's going to be important here when we want to go backwards. Well, it's still 1. I said it's still 1. If 1 is 2/2, or 3/3, or 4/4, considering that, and any number is itself times 1, right? Then we could say 2 is the same as 2 times 1, or 2 times 2/2, right? We can multiply it over whatever we so choose. Remember that 2 is 2 over 1, and remember how to multiply fractions, the tops and the bottoms. Okay? Well, then 2 could be written as 4/2, couldn't it? You just changed a number to an improper fraction, where the number on the top is bigger than the number on the bottom. They're equivalent. We could also say that 2 is the same as 2 times 3/3. Multiplying, I could get 6/3. So 2 is the same as 6/3, isn't it? 5, I could say, is the same as, if I could pick any fraction I wanted, anything over itself. Let's use 4 over 4. As long as you multiply the top and the bottom, it's 20 over 4 is the same as 5. Okay, interestingly enough. Well, so the idea of writing a mixed number as an improper fraction, here's what we're going to do.
Wait a minute.
To multiply and divide. Why would we do this? Because while the mixed number is easier to graph, the improper fraction is easier to manipulate. That's why we're going to do this. Okay? So what we're going to do is multiply the whole number by the denominator. Okay, and that'll give us, and then add the numerator to that result. And we're going to write our result over the original denominator, because we want to make this one big fat fraction. Okay? So let's do it. Let's multiply the whole number by the denominator, the 3 times the 2, and we get 6. And then what do we do with the 6? Add the numerator of the fractional part, 1. And what do we get? 7. And then what do we do? Put that result over the original denominator. Uh-oh, we have an improper fraction here. And that's what 3½ is. It's the same as 7/2.
Whoa! Someone smells stinky!
That's okay. We wanted it.
It's me.
We wanted an improper fraction. Let's do it again. Let's go through the steps. We're going to multiply the whole number part by the denominator. 4 times 9. Okay, we get our answer, 36. Then we add the numerator part of the fractional part of this mixed number. Add a 2. We get 38. And then what do we do with the 38? We put it over the original denominator. And there you go. 38/9, believe it or not, is the same as 4 2/9.
And another thing.
Of course, so that if we want to multiply mixed numbers, now that you know how to change them into improper fractions, watch how easy this is. We're going to take the rule for multiplying fractions, a over b times c over d, is just multiply them. A times c over b times d. Okay, for example, I want to multiply 1/3, you knew this, times 2/7. We're just going to multiply across, right? And I get 2/21. Now that has nothing to do with mixed numbers because they're not mixed numbers. Well, what happens when we have mixed numbers? We're going to use the same rule. Now sometimes some canceling is involved here, okay? Don't forget, for instance, in this problem, 1/15 times 5/11, you might have to cancel. And you want to cancel before you multiply so you don't get high numbers. Don't forget that, okay? So for instance, in this one, I'm going to cancel the 15 with the 5 first so I don't got to multiply that high number. Let's see, 5 goes into 5 once, and 5 goes into 15 3 times. So I made it a much easier problem. So that's the idea of multiplying fractions once they are fractions, okay? So let's take that same rule
Yeah, baby, yeah!
and use it to multiply mixed numbers. Here we go, baby. Well, I don't know how to multiply these, so I'm going to change them into improper fractions. So let's see, 3½ written as an improper fraction is 7/2. 3 times 2 plus 1/2. Okay? 1 1/3 written as an improper fraction, 1 times 3 plus 1 is 4/3. Oh, now we can do it. Cancel if you need to. I get a 2 going into both of those. 2 goes into 2 once, 2 goes into 4 2 times. Any more canceling? I don't see any. So I just multiply across. 7 times 2 and 1 times 3, and you got yourself an answer.
You're absolutely correct.
Okay, so to multiply mixed numbers, we don't. We change them into improper fractions and then multiply.
Thank you, sir. May I have another?
I thought you might ask for that. Let's take a look. We're going to change this one into an improper fraction. And then we're going to multiply normally. 2 times 3 plus 2. So we have 8/3. Now what is 6? What the heck is 6 as an improper fraction? Remember, any number is itself.
Now what am I going to do?
Well, you remember, any number is itself over 1. That was easy, okay? Cancel if you can. Oh yeah, the 6 and the 3. 3 goes into both of those. 3 goes into 3 one time and into 6 2 times. And son of a gun, we canceled like a mug. 8 times 2 is 16, and 1 times 1.
Is that your final answer?
I don't think we want to leave it as 16/1, Regis.
Say, you're plumb right.
Remember, anything over 1 is itself. That's it.
Yes!
We got it. Okay, get the idea, and the idea of bringing in 1, getting rid of 1. You can throw 1 around like cheap meat, okay?
Yoink.
How about this bad boy? Dividing. Remember the rule for dividing. You take the first fraction and multiply it by the reciprocal of the second fraction. Okay? For instance, what are we going to do here? Well, we can't do it, can we, until we make them improper fractions. Let's make 3 times 2 plus 1 over 2. Make that into 7 halves. And 1 1/3, 1 times 3 plus 1. Okay, now how am I going to divide these? I'm not. I'm going to multiply by the reciprocal. Now it's not so bad, is it? All roads meet at improper fractions. That's what I always say. Have any canceling? I don't think I do. So I just have it. 7 times 3, 21. 2 times 4 is 8.
Hey, you're plumb right, Farman.
Not so bad, huh?
Excuse me, Professor Brainiac.
Oh, I got to show you one more thing today. This is so cool, okay? Remember your LCD was the answer for adding fractions. Where do you see this?
Houston, we have a problem.
Look at this equation. Holy, go to war. That would be tough, wouldn't it?
Go!
You hate it. You know why you hate it?
I hate you.
Because you hate fractions. Okay? Well, so you know what we're going to do?
Now what am I going to do?
We're going to get rid of all the fractions before we even start. And I've got a secret. This is a job for
LCD man.
LCD man.
Here I come to save the day.
You love LCD man. You would marry LCD man. He's lower than low, and he can cancel out denominators in a single step. Let's see it. Let's go back to this nightmare.
LCD man.
Wait a minute. The trick here is if I multiply everybody on the left by LCD. Oh, I forgot. I have to do it
LCD
to both sides.
man.
Let's see if this helps me. What is the LCD?
Perhaps I could be of some assistance.
Well, let's do it. To solve a fractional equation, you find the LCD and multiply everybody by it.
LCD man.
Let's see. Everybody on both sides. What is the LCD?
Here I come to save the day.
It doesn't look so good right now, does it? But watch what happens. 6 cancels with 2. Ooh, baby. It's not a fraction anymore. 6 cancels with 3. Ooh, I'm getting rid of fractions. I'm cleaning up big time. 6 with 1. Bam! Now I'm not done yet, but at least I've gotten rid of all the fractions.
What happened?
Well, the LCD canceled everybody out. He's the hero. So let's finish this bad boy off. 3x plus 2x, 5x. Now we got to get that x by itself. Divide by 5, and x is 6/5.
You're absolutely correct.
Wow, that wasn't so bad.
Do that again.
Okay, let's do another one. Ooh, look at this bad Johnson. Let's see, what are we going to do with a fractional equation?
LCD man.
Okay, what's the LCD of every fraction involved? Let's see, I got 7, a 2, and a 2. What would be the least common denominator of all those babies?
Here I come to save the day.
Apparently 14. I'm promising you will fix everything up. Let's see. That's why we found LCDs. That cancels, and I get a 2. And 2 times z is, well, that's not that bad, but at least it's not a fraction. Okay, that cancels, and I get a 7. Of course, you got to multiply 5 times 7. Get you 35. Got more cleanup over here. That cancels, and I get a 7, and I get 7z. Now I got a problem that I know how to do. It's got, you know, all the fractions are gone. Let's see, what are we going to do first? I think I'll pick on the little guy. I'm going to subtract 2z from both sides so that all the z's are on one side. Okay, now they're all on that side. Who's bothering me? 35's not bothering me. It's that 5 that's keeping z from being alone. He's multiplying, so I'll divide. And son of a gun, z is 7.
You look marvelous.
That was not so bad, was it?
I make this look good.
It's easy. Your mom could do it.
Thank you, sir. May I have another?
Okay, just one more. Who's the troublemaker here? The -6/11. Okay, so what's the least common? It's an easy least common denominator this time.
LCD man.
It's only one, 11.
Here I come to save the day.
But you got to do it to everybody, okay? And I promise if you do it to everybody, everything will clean out. Let's take a look. On the left side, you just multiply. Of course, that could be 3x over 1, that minus 3x. So we just multiply, and we've gotten rid of the fraction. These 11s cancel, and bring down the -6. Now who's the troublemaker? The -3. It's -33. And he's multiplying, so I'll divide both sides. And I get x. Oh, the negatives canceled too. I get x is 6/33.
Is that your final answer?
Oh, remember on our tests that I'm going to take off if you don't reduce. Because I showed you how to reduce. You should know how to. Let's see, 6/33. I can divide both of those by 3. Okay? 3 over 3, of course, is 1. So I'm not doing anything illegal here. And I get 2 11ths. 6 divided by 3 is 2. 33 divided by 3 is 11. And kumbayama.
Remember.
Okay, let's review what we've done here.
Remember.
To create a least common denominator, because we're going to use that for a lot, we're going to break up the values that we have as far as they'll go into their prime factorizations. And then we'll construct a term that contains at least every factor from both sides, both sets.
Now look at, I say,
Let's do
look
one.
at here.
Let's make a common denominator from 20 and 15. Let's break 20 up as far as it'll go. Okay, 4 and 5. 4 breaks up a little bit further. Okay, and that's as far as he'll go. And 15, as far as he'll go. And then we have to construct a term from and make sure we've included everybody. So I need a 2. I need 2 2s, actually. I need a 5. I need a 3 from over here. I need a 5, but I already got a 5, and I'm trying to keep things small here, so I'm good to go there.
Oakley dokley doo.
So there's my answer for the least common denominator, 60. Let's take roll. Is 20 in there? There he is. Is 15 in there? There he is.
Oh, gnarly!
There's your least common denominator, and there's your method.
This thing isn't as black as it appears.
Okay, we're going to add fractions. Of course, if they have like denominators, it's easy. Just add the tops.
Totally.
If they have the same denominators, just add the numerators. Even if it's a tough denominator, like a y. They have the same bottom, just add the tops.
Gnarly.
Goony goo goo. Now if they have different bottoms, what do? Well, we're going to have to find LCDs then. Let's see, in this case, it's not so bad. The least common denominator would be 6. Okay, we create equivalent fractions with the same denominator. Let's see. 3 times 2 is 6, so remember we had to multiply the top by the same number. The reason we could do that is because we were really multiplying by 1. So we got 8 here. 2 times 3 is 6, so 1 times 3. And then now we have 2 fractions with the same bottom.
Oh, gnarly!
And we just add them up.
Genius. That's what it is. Sheer genius.
That was easy. Okay, then we worked with mixed numbers. Switching back and forth. We're going to switch them from an improper fraction to a mixed number by dividing the numerator by the denominator, taking the answer, making it the whole number, and taking the remainder and putting it over the fraction and making it the fractional part. For instance, 7/2 is 7 divided by 2, gives me 3, remainder 1. That's going to change into 3 and 1 half. See how we did it?
Cool.
Okay, now let's work backwards. That's improper to mixed. Mixed to improper.
Wait a minute.
We can do it. We multiply the whole number by the denominator, then add the numerator and put it over the original denominator. Multiply the whole number by the denominator, add the numerator, and put that over the original denominator, and we got ourselves an improper fraction. That's the way we do it.
Whoa! Someone smells stinky!
Okay, one more thing.
How about a little fire, Scarecrow?
To multiply these things, we changed them to improper fractions and then multiplied. So that wasn't so bad. We had to cancel sometimes.
You're absolutely correct.
Okay, so all roads meet at improper fractions.
Perhaps I could be of some assistance.
And lastly, to solve an equation, multiply everybody by the least common denominator.
Here I come to save the day!
And they'll cancel like a jimmy. You're loving this. It's cleaning up like there's no tomorrow. And once you have no fractions,
What happened?
just solve things normally. Dividing by 5, x is 6/5.
You're absolutely correct.
Okay,
Hasta la vista, baby.
that's enough for today. Let's see what...
Code Red, repeat. We
Uh-oh.
are Code Red.
Oh, I know, it's time to...
Oh, good grief.
It's time to take a test. Okay, make sure you go do your homework and do that practice test. Above all, make sure you do that practice test. Go to the assessment center and take the next test. Okay? And remember, when you're doing your homework, don't be looking at it. Do it. Actually take the pencil, put it in your hand, and do it. Okay? If you have any problems, don't be afraid to call me. Well, you can always go to your old buddy the homepage at www.montgomerycollege.edu/prealgebra or email me at bwitte@mc.cc.md.us. Thanks for listening. Thank you. Thank you very much.